Have you ever wondered why we see rainbows, where light comes from, and what makes the best shadows? Well, today we can find the answers to those questions and more as we explore light. If you'd like to have a go with these light activities, there's a few pieces of equipment you might need. We're going to need a little bit of water and a tray to pour the water into. We're going to need some clear nail polish. We're going to need some black card or paper. We've got a clock face template, a pair of scissors, some blue tack, a paper plate, a pencil, some glue, some white card, bits of cellophane or sweetie wrappers. There are many sources of light, both natural and man-made. The biggest source of light that we have here on planet Earth is from our nearest star, the Sun. In fact, if the Sun was to disappear from our skies right now, we wouldn't know for another 8 minutes and 20 seconds. It's that far away. If we look up at the sky at night time, we can see all those other stars too. Whilst we're looking up at the night sky, we can also see our moon, and our moon reflects the light that the sun shines onto it. So whilst it can provide us with nice bright light, it's not a direct source of light because it's not making it. Before electricity, fire was one of the earliest forms of light in our homes. We'd have lots of candles to help us see at night time. Some animals can actually make their own source of light. Such examples of fireflies and glowworms, they actually have a specialised light emitting organ. And in that organ, there's a chemical reaction that happens which creates light. The majority of creatures that we find that emit their own light are found at the dark depths at the bottom of the ocean, where we can have crustaceans or starfish or jellyfish or even anglerfish creating and emitting their own light. Now, some of these creatures actually source their light from bacteria, and it's the bacteria that are capable of doing the chemical reaction that makes the light rather than the animals themselves. Man-made sources of light, such as light bulbs, and we have various different types of light bulbs from fluorescent lamps to LEDs, can produce light as well. But there is a slight difference between natural light and man-made light, and that's all to do with the wavelength of light that's being emitted. These sources of light are made up of what we call white light, which is a mixture of wavelengths, and each of those wavelengths corresponds to a particular colour. On a day where we have water droplets in the sky, but it's nice and sunny, we might be lucky enough to see a rainbow. And a rainbow happens when the light shines through the water droplets in such a way that it breaks up all the wavelengths of light coming from the sun. When a source of light is broken down into its individual wavelengths, we actually see them as different colours. And if we look at a rainbow has 7 colours: red, orange, yellow, green, blue, indigo and violet. Each of those different colours correspond to a particular wavelength of light coming from the sun. We call this process diffraction. Raindrops in the sky are not the only place that we can see this happening. We can also see it in oil slicks and even in bubbles. These liquids also have the potential to diffract the light and reveal the rainbow colours inside. So let's have a look how we can make rainbows in our own homes. An easy way to investigate rainbows is to use a CD. A CD has a surface that diffracts the light into those rainbow colours. Beyond that, we can make what's called a spectroscope, and that's where we've got a little black box with a hole in one side and a slit in the other to insert the CD. So we're going to slot the CD inside, with the shiny side facing inside the box, and then when you look through the hole, you can see those rainbow colours. Bubbles are a great way of seeing a fluid rainbow being formed, but if you haven't got that, here's a simple trick that we can capture rainbow light. So for this experiment, I've got a little tray of water, I've got my clear nail polish and a pair of tweezers, and I'm going to be trying to trap a rainbow onto a bit of card like this one I made earlier. So we're going to take our bit of card and we're going to be ready to put it onto the surface of the water after we've dropped a little bit of the nail polish on. So we just want a drop of nail polish to hit the surface, and as it does, it's going to spread out. And that's because our nail polish is a solvent, and what that means is it's not going to mix with the water. So instead, it creates a very thin film over across the top of the water, and that is enough to create a cool rainbow effect. We might end up having to dip our piece of paper more than once. There we go. So we can see I've managed to capture a bit of the rainbow film on this side of the paper. Now I can cover the other side with a bit more, so if I add another drop on the water, it's going to disperse again. I'm going to re-dip my paper. I can actually see where the film is, and it's kind of creating a sort of almost plastic cling film like layer. And I can pick it off again. Now we've got a really good rainbow bit there. So we're going to need to dry it off for it to fix on the paper, and at this point that thin layer of nail polish could actually peel off quite easily. So here's one that's already dried, and you can see how well that's trapped the rainbow pattern. Have a go for yourself and see what kind of effects you can make. An even easier way that we can see rainbow colours is with a pair of these special diffraction glasses. So these glasses have gratings in the lenses that break up the light into those rainbow colours. So if I pop them on, I can see all sorts of rainbow colours wherever there's a source of light. I can show you through the lens, and it works really well if I shine a light at you. In 1666, Isaac Newton discovered you could use a glass prism to split up light into all those wavelengths and reveal the rainbow colours. So this is an experiment we're going to try. Here I have a light box and a triangular shape glass prism. Now we're not going to be able to see this very well in the light, so I'm going to pop into a blackout tent and show you this demonstration. As we turn the light on and we place the prism in front of the light, just changing the angle ever so slightly can reveal how the light splits up into all of those rainbow colours. Since this discovery, scientists have been able to use other shaped prisms to create different effects. So with the light box, I've actually got 3 lights that can come out at the same time simultaneously, and we've got 2 different prism shapes that we're going to investigate. So this is a double convex prism where both sides are rounded and wider, and this is a double concave prism where the sides are narrower in the middle. We're going to test these out in the blackout tent. So with the 3 lights switched on, we can see that they are travelling in a parallel line, so they're all equal distances away from each other. And when we put the double convex lens in front of it, we can see that it's being refracted through the prism and the lights are narrowing to a point. If we try the same thing with concave prism, we can see that the lights refracting in a different direction, making them further apart. Understanding how light travels through objects like different shaped prisms has actually enabled scientists to produce glasses or contact lenses to correct people's visions. We can use more convex or more concave lenses according to the prescription that that person needs. Another form of light that we can look at is laser light, and laser light is an individual wavelength of light rather than a mixture of wavelengths which we see in white light. So here I have a laser box, and this laser is showing a red wavelength of light. We can see the source that it's shining from, and we can see where it's hit my hand. Interestingly, we can do a demonstration with our laser light to reveal that light travels in a straight line. In order to do this experiment, I'm going to need to go in the blackout tent. So I'm going to take the laser light, a couple of whiteboard dusters and a bit of talcum powder. And what I'm going to do is I'm going to put the talcum powder on the dusters and I'm going to tap it over the top of our laser beam, and we should be able to reveal that light. So here in the blackout tent we have the light, so we can see the source and where the light is hitting. And if we take the talcum powder, we can tap it over the beam of light and we can see that this beam of light is revealed. This is happening because all those tiny little particles are allowing the surface for the light to bounce back. Light travels in a straight line. It doesn't bend. It actually bounces off of different surfaces. So if we wanted to get our laser to go in a different direction, we'd need to use a mirror to get the light to reflect. So in our blackout tent, we can see if we put a mirror in place, the light is now bouncing in another direction, and we can reveal that laser beam with the talcum powder. So now you can see the light travelling from the laser to the mirror and the mirror onwards. If you have a laser pen at home, you can try this experiment for yourself. But don't forget, lasers are dangerous. We need to keep them away from people's faces and we have to protect our eyes. At the end of the rainbow, we have the most energetic wavelength of light, violet light. And beyond that, we have ultraviolet light or UV light. This type of light is what we need to protect ourselves from when we're out in the sunshine. Because it can penetrate our skin, it can cause sunburn. So we try to protect ourselves from ultraviolet light by putting on sunblock to block the light out from our skin, putting on a hat or going into the shade. And these things are enough to stop the ultraviolet light from damaging our skin. This is a type of ultraviolet light or UV light, and it's called a black light. And it's interesting because it won't light up the room, but it does have an effect on some colours. So here I've got a range of highlighter pen ink. So we've taken the inks out of highlighter pens, and if we put them in front of the ultraviolet light, we can see they have this amazing effect of making them glow. So these highlighter pen inks are called fluorescent. These highlighter pen inks have fluorescent dyes inside, and fluorescence is where a particular molecule inside of the dyes gets excited by the ultraviolet light, and it hangs on to that energy for just long enough to make it look really bright. Now if we were to turn the light off, we can see they're not glowing anywhere like as brightly as before. Now ordinary water will just allow the light to travel through, but this is tonic water, and tonic water has something called quinine inside, and quinine is a molecule that can react with the ultraviolet light, so it gets excited and hangs on to that energy for a bit longer. But the moment we move it away from the light, it goes back to looking like normal water. Here's an experiment we can do with a special chemical called fluorescein. So we're going to take some water into our beaker here. We're going to use this dye, and you can see this dye doesn't really glow in front of the ultraviolet light, but as soon as we add it to the water, we get an amazing reaction where the fluorescein has now reacted with the water and made it glow. We have a fluorescent dye. These liquids are called photochromic liquids, and right now we can see they're colourless and transparent. But as soon as we turn our ultraviolet light on and let them absorb the energy from the ultraviolet light, instead of fluorescing like our highlighter pens and our fluorescent dye did, they do something different. These chemicals have molecules inside that hang on to their energy for a lot longer. So long, in fact, they change colour. So this one has now gone purple, and this one has now gone pink. And the longer they stay in front of the ultraviolet light, the darker those colours get as they get more and more energy. Now if we take them out of the ultraviolet light and leave them in a dark place, they'll lose that energy over time and they'll go back to being clear and transparent and colourless. There are some pretty cool toys that use ultraviolet lights as pens. And this is a special material that reacts with the ultraviolet light. So when we draw on it, it hangs on the energy and it emits light. So we'll go to the blackout tent and give it a go. So you can see we can use the light to write a message. Without light, not only would we not be able to see, but we would have shadows to play with. Shadows are a great way of exploring light, and here's a simple experiment you can do at home in your garden. So if we look at where the sun is positioned at different times of day, we can see what effect it has on our shadow. So as the sun rises and sets, you'll find it's in a different location in your garden from morning to afternoon. If you draw a spot in your garden that you stand at and face the same way at different points during the day, you'll find that your shadow changes in length and position. If you like, you can have a helper draw round the shadow that you cast so that you can keep track of where the position of the sun is. Shadows are not only really fun to explore, but they're useful. In fact, we can use them to tell the time. Let's have a go at making a sundial. For this, you might want to print out a clock face, or you can draw your own. Once we've printed it out, we're cutting it out, or you can draw it straight onto a paper plate. We're going to stick the two together. I'm going to put a little bit of blue tack in the centre of the paper plate, and I'm going to push a pencil through the plate and the paper and stick it into the blue tack. And that's a very simple sundial that we can use. So on a nice sunny day, you can take your sundial into the garden and line it up with the position of the shadow of the pencil. So as the sun's shining out this way, I can see my shadows casting and I can turn it round to find the time. So it's about 3:30, which is about there. You might find you need to adjust the position of your sundial so that it can accurately tell the time during the day. Shadow boxes are a really good way of learning about light and shadow, and they're really good fun. We've made one very simply using a packaging crate. So we've taken the crate, made a hole in the bottom, and we've put a bit of tracing paper at the front there to project the shadows onto. And then on the back we've got a lamp that we've been able to clip onto, and we've made some little characters out of card to cast a shadow. Not all materials can produce a shadow. They have to be able to block out the light in order to do so, and we call that opaque. So if something's opaque, the light can't travel through. If something is completely see-through, we call it transparent. So here we have a light box, and we can see that our transparent material allows us to see completely through it. And that's really useful, like with glass in a window, whereas opaque is it will block out the light. In between that, we have translucent materials. Translucent materials block out some of the light, but allow some of it through. This is really useful for things like stained glass windows, allowing the light to travel through, but taking the colour with it. You can explore various objects in your house to see which objects are translucent, transparent, or opaque. Once you've found some objects, you can put them in your window and see what effect they have. If you'd like to do something crafty, you can have a go at making your own stained glass window. For this effect, we've taken a piece of card and I've folded it in half, and I've just drawn on some simple shapes on one half of the card. If I cut the shapes out down the fold line, then we'll get a symmetrical pattern on both sides of the paper. So when we unfold it, we've now got a rectangle shape. in the paper. We can then use bits of cellophane or sweetie wrappers to colour those holes and add a stained glass effect. If you don't have any cellophane or sweet wrappers in your house, you could use some plastic material and colour it in with permanent markers. If you have a hole punch or a special shape cutter like these hole punches here, you can create some other effects. So here I've used it to cut out a little picture with some stars, a UFO and some people, and then I've added the sweet wrapper behind it to create my stained glass window effect.